The Near Futurist, a podcast with Guy Clapperton. Hello, and thanks for downloading The Near Futurist, a show presented by me, Guy Clapperton. In this episode, we're going to look at machine learning. Can machines really teach themselves without bias or building in human error? First, as usual, a little bit about who you're listening to. And this time, you'll be relieved to hear I've got something new to say, actual news. I'm Guy Clapperton, a technology journalist with 30 years experience as a commentator in The Guardian, Times and loads of places. You probably know that if you've listened before. So this time I'll tell you I'm doing something a little new. The Near Futurist podcast is owned by my company, Clapperton Media Associates, and we've started doing a little corporate social responsibility. We've sponsored a beehive under the Bees for Business banner. Bees are in trouble. Their numbers have diminished and they pollinate around 30% of our crops here in the UK. So I thought if my subject is the future, I might as well make a tiny contribution to safeguarding it. Back to the podcast though, do have a look at my website at nearfuturist.co.uk where you'll find more episodes and information on what we're about. If you'd like to book me as a speaker or MC for your technology event, do have a look at the show reel on the site and drop me a line, guy@nearfuturist.co.uk, that's nearfuturist is one word, or get in touch with my agent, whose details are of course on the site. If you like what you're hearing on this podcast, please do consider leaving a review on the iTunes Store or wherever you download from. And if you've done so already, thank you very much indeed. If you're new to the show, of course, a very warm welcome to you. That's more than enough about me. My guest today is a technologist with substantial experience of both large and small companies. He spent more than 7 years at Juniper as Chief Technology Officer for the security business. He secured this post as a result of Juniper's acquisition of Funk Software, where he was CTO, better known as developer number one for steel-belted radios. Before that, he co-founded Trilogy Inc., and prior to that, he did stints at Novell, Fluent Machines, and IBM. Now CTO of Vectra, his name is Oliver Tavakoli. Oliver, welcome.
Thank you, Guy.
Good, and thank you very much for joining us. So first, perhaps for people who don't know, you could tell us something about Vectra.
Sure. Vectra is a company that I joined almost 6 years ago now. And after spending, I would say, 20 years or so in the cybersecurity business, in what I refer to as the more traditional side of cybersecurity business, Vectra was a departure for me because it was really looking to solve problems through the application of machine learning and artificial intelligence to the defensive side of cybersecurity.
You're clearly very interested in the machine learning side of things. So perhaps you could take this right back to basics. I've been a technology journalist, as I say in the intro, at great length, for 30 years. And I keep hearing that robotic process automation is different from artificial intelligence, which in turn isn't quite the same as machine learning. So for people who are unfamiliar with these terms, and believe me, I could do with a refresher,
Sure.
Could you perhaps explain what all these things actually mean and which one's which?
Yeah, I think zooming all the way out, artificial intelligence, I know people tend to think of it as a very specialized term. It is actually a pretty broad term that was coined way back in 1956. It's been around long enough to have gone through three winters, AI winters, i.e., where you reached an age of disillusionment and cuts of funding and cuts of research through the various decades between then and now. So artificial intelligence at the highest level is simply like, can we make things that seem more intelligent than we imagine machines could be? And obviously the bar for what is referred to in the industry as artificial intelligence shifts over time. If you traveled back in time and handed somebody, 40 years ago an iPhone with Google Maps on it, with traffic processing, and you could just enter an address and it would tell you which route to go based on what the traffic conditions were and such, then you would have referred to that in those days as that's artificial intelligence, because I can't imagine how this would work. So we should just recognize that term of art is something that is an imprecise term. It has shifted over time. In the 80s, it was all about expert systems, which basically meant you went and interviewed experts and you then implemented the logic that was in their heads, and that was considered artificial intelligence. We're in an age now where artificial intelligence crossed with machine learning is really the thing that's in vogue. So it's not about getting subject matter experts and understanding what's going on in their heads and writing that as traditional code, but instead it is using a series of mathematical methods to learn from data to extract out that looks slightly intelligent. So,
Okay, so if I've understood this correctly, the old-fashioned, if we can call something that's still relatively new, old-fashioned, but the older version of artificial intelligence was perhaps a little bit more to do with parroting, sort of repeating expert information back at you, whereas the current version is more to do with the machines learning from data and extrapolating from data.
you couldn't really easily imagine doing machine learning type of AI in the past.
No.
So really it's the confluence of our penchant for collecting data in an internet age and in an age where compute and storage is abundant that actually allows that avenue of kind of artificial intelligence to proceed.
So in this instance of machine learning, are machines learning from machines or are they learning from humans?
It's an interesting question. I mean, you know, there are things like robotic process automation. Effectively, machines are observing what humans are doing and mimicking that. I would actually not go as far as, like, it really depends on how sophisticated it is in order for you to actually refer to it as artificial intelligence. If it's simply a question of, hey, you know, I see this person press these 20 buttons in a row all of the times, well, let me just give them one button that automate those 20 buttons. Or can I recognize the conditions under which a user decides to take certain actions? And as long as I can recognize those conditions, then I can perform those actions in an automated way. So I don't think any of us, you know, looking at Terminator or something like that would look at that and say, that's artificial intelligence, right? It's simply a means of automating, as has always been true. I mean, there's always an effort to automate actions. And by observing users, you can either do that manually, you can observe users and create that automation, or you can have machines observe end users and learn those patterns, which is effectively what RPA is.
Yes, RPA is very strictly rules-based, isn't it? It's this sequence is triggered by this, and there's no imagination or extrapolation attached to it. That's my understanding.
Correct. Since the Industrial Revolution, right? I mean, we've been trying to automate things, right? Yeah. And RPA and, you know, machines learning, observing and learning is simply, you know, the final step in that frontier. It doesn't really require a lot of deduction. Whereas if you look at other examples, you know, an interesting example, for instance, is you know, playing the game of Go, which, as you know, is a far more complex game in terms of the combinatorial possibilities than something like chess. So Google, you know, famously created the initial version of its AlphaGo program by effectively having a machine ingest a record of all of the games ever played and the outcome of those games, so games played by humans. And it attempted to learn from that. Okay, I should learn to play this way, that way, right? And it was quite good. But then they decided to actually use a very different technique for the next version, which is, let me just explain the rules to a machine, you know, the rules by which you can play, and how to judge outcomes as to whether they're positive or negative, and then have machines play each other, a simulation of, you know, 10 billion, 10 trillion games, and effectively learn the sets of moves, the patterns of movements that are more likely to lead to positive outcomes, right? So it is a combinatorially large enough problem that you can't simply, unlike tic-tac-toe, you can't simply plumb all of the moves, but you can find out patterns of movements that are more likely to lead to success versus failure. In that case, machines are playing machines, and they're learning from each other within a constrained world, obviously, within a constrained world of this one game.
Okay, I can see that. I can see that that could also be quite complicated, even in the case of tic-tac-toe, or as we call it in the UK, noughts and crosses, because there are still a number of variants, and you know, you even rock, say, paper, scissors. You can
Rochambeau, as we would call it. Yes.
But yes, sure. We can swap jargon all day. But I'm just wondering, if you get away from the games, what is the actual benefit of I can see that these things are really interesting. That in theory a machine can play, whether it's Go or tic-tac-toe or chess. What benefits are there in the real world?
Well, I mean, in the real world, we haven't kind of dug down into kind of genres of machine learning. So in the real world, when you kind of get into the, you know, various machine learning techniques, I mean, most generally, you tend to think about supervised and unsupervised learning.
Yeah.
And generally, the problem that you have is you're going to process data. You're going to want to process large amounts of data. Sometimes the data has labels, and sometimes it does not. So, you know, again, a famous kind of thing that Google and Apple and others have done which has some utility to it. Go onto your phone, open up your photo app, and type in the word cat.
Mm-hmm.
And it will, interestingly enough, pull up all photos that you have in your photo roll that have cats in them. And you kind of go, well, I didn't label them as cats. Well, but Google had a large enough corpus of things that either were manually labeled or customers have happened to label with the word cat. And so they had a pile of images that had the word cat associated with them and a pile of images that did not have the word cat associated with them. And then it trained a program to learn the difference. So it doesn't mean that you can necessarily type in any word. You can't type in wrench and have it find pictures with a wrench in it because they haven't programmed that word. But in as much as you can process a lot of images and recognize things in them, in as much as you can process a lot of speech or text and recognize things in them, there's clearly utility to it. Even Google's translation engines are an example really of using machine learning to actually learn how to teach a machine how to translate, and to translate in a way that you don't end up with awkward sentences in the target language of your choice. If you look at things like Google Translate over the years, it's gotten phenomenally better. If you're bilingual, you can do some experiments going from one language to the other, and it's like, yeah, that actually sounds okay. May not be perfect, but sounds okay. So there's a fair bit of utility compared to trying to write a program that does perfect translation, compared to trying to write a program by hand that recognizes certain images in things. And these are still things that are generally useful but don't change the world in a dramatic way. Obviously, self-driving cars is another example where we've taken a relatively narrow constraint problem, which is how do you operate an automobile, and we've made it more complicated by saying it needs to be in the chaotic world that we live in amongst humans that are going to do unpredictable things, and how do you make them effectively drive from point A to point B without killing anyone and while doing so in an efficient way. So there are a number of different places that effectively ML can be applied.
Now, that's an interesting one, isn't it? The idea of without killing anyone. Quite seriously, yes. That's the one we're going to have to get over eventually if this is going to work, because there is no such thing as a human who is incapable of driving without killing anyone. We won't do anything like that. We all strive to avoid it, but it does happen. So at some stage, I think someone is going to have to take the decision about how many people it's permissible to kill. And that's that. When you put it in those terms, it's quite cold.
It is and it isn't, right? I mean, at one level, you can look at this statistically, right? If we look across a large population, we can say with reasonable certainty how many people get killed by human error on roadways in a given year.
Mm-hmm.
And it'll also be true at some point that we will be able to prove statistically that if those cars were self-driving, the number of people killed will be far fewer, but it will not be zero.
Yeah.
And so now the interesting moral argument sets in, right? Do you hold a machine to an impossible standard, given that it is in a world populated by humans who do unpredictable things? Anytime a self-driving car at this point, or a car on kind of self-driving kind of autopilot causes a death, it'll be national news in the US. And anytime somebody locally, makes a mistake and hits someone and kills someone, it will not. And so it is just our fascination with, well, the machine should be perfect, that in some way stands in the way. But this has always been true for automation. Whenever you've put automation in place, it has had to overcome that barrier. I think with artificial intelligence, we just get a little more pedantic about it because we feel that it mimics human behavior. And so therefore, we feel like we should know exactly what it should and should not do. And we like to second guess it all the time.
Now, of course, you've applied an awful lot of this to the security world in your current job, current position. And I'm just wondering, the other thing that comes in at some stage is the notion of deep learning. I wonder if you could give us an idea of what exactly that is and how it applies to security, why the world is more secure with it than without it.
So deep learning in general is a certain subspecies of machine learning. It can be supervised or unsupervised, so it doesn't fall neatly into one side or the other. But generally speaking, when you think about machine learning, you think about processing large amounts of data. And as you process these large amounts of data and you learn from them, you have a representation, a somewhat compact representation of what you have learned. At its simplest level, it could just be a simple mathematical formula that if applied to the data, let's say the data is labeled, there's cat and non-cat, and if you run this mathematical formula, if it comes out to be 1, it's a cat. If it comes out to be 0, it's not a cat.
Mm-hmm.
That would be a very compact representation. The problem is that ultimately, if you process visual data, images, you're unlikely to come up with that kind of a compact representation. And so what's actually required mathematically is a more complex thing. So there are these things called neural nets, neural networks that have been kind of constructed over time, which are effectively ways of building engines that learn from data and that can learn in a pretty sophisticated way. They can learn pretty subtle patterns and patterns that have a fair bit of information in them. And then there is so if you think of a neural net, it's like you have a series of inputs on the left. You have, a set of neurons that you drive those inputs through that perform some mathematical calculation. And then on the right-hand side, those neurons then combine again to give you a classification, cat or not cat, dog or not dog. Deep learning basically involves running deep neural nets, right? So think of it as you have a series of neurons that perform a first layer of operation. The outputs of those neurons go to a second layer, which performs a different set of operations. The outputs of that goes to a third layer, fourth layer, fifth layer, etc. The deeper the network, the deeper the neural net. And so deep learning are a series of techniques that are around kind of perfecting these deep neural nets. And the neural nets are oftentimes thought of as something that really tries to reproduce how the human brain actually works, how neurons work in the human brain. But think of it as a small section of the brain. Like if you train up a neural net that can distinguish photos of cats versus non-cats, just think about the small amount of your brain necessary to do that. And that's still a reasonably complex neural net in the context of kind of machine learning. So deep learning is just one of the more sophisticated techniques right now in terms of how to express very complex relationships potentially in the data set and to express them with as high a fidelity as possible.
And of course, you're in the security field. Can you tell us something about how deep learning, machine learning, all this stuff, actually how it makes us safer, how you're applying it?
Well, I mean, the interesting thing is it does and it doesn't, right? It's, like any tool, it is available to attackers as well as defenders. And the way to kind of think about it is you cannot choose to not play in this game because the attackers will have no compunction about using this same technology. Unlike a game of Go or a game of chess, where two parties are playing the same game, in the cybersecurity, there are two very distinct roles, right? I'm not trying to destroy the adversary. Generally speaking, I can't find the adversary. I can't exactly locate the adversary, but yet I have to defend myself against attacks by the adversary. And so I'm playing a very different game than my adversary. And as a result, basically machine learning and AI have already been applied to a certain degree by attackers. I don't think we've really seen quite a renaissance on that end. And for the defenders, there is an inherent advantage to actually using AI and ML. So for the defenders, it's basically, if you think about it, is if I'm inside the environment that I'm trying to protect and I can observe it and learn from it over a period of weeks and months, then I have using AI and ML, I can have a pretty clear picture of what should be considered normal and acceptable and what should be considered extraordinary and unusual. And on the other hand, if I'm an attacker, what I can automate with AI and ML is the probing of the attack surface. But once I get into the actual environment that I want to attack, the problem is that I don't actually have a lot of data. It's not like I can run a million simulations offline that prepare me for the day when I am inside a customer's environment. So for the attackers, AI ML becomes really more about how do I get my foot in the door. So where you see attackers use that is in spear phishing campaigns. Let's say I decide, Guy, that I want to increase the likelihood that you will click on a link of an email that I send you that will infect your machine. What I would, as an attacker, do is basically say, okay, rather than me going and reading, Guy's Facebook page and his LinkedIn page and, everything about Guy, and then trying to fashion the perfect email, I can just use kind of an automation robot that does that, scrapes all of that information, recognizes the fact that, hey, Guy just went on vacation with a friend of his a week ago in Mallorca. And so I'll craft an email that says, hey, had a great time with you in Mallorca. Here's a link with some pictures from our vacation. And it's like, you're more likely to click on that. Why? Because it's topical. It clearly, it knows something about you. And yet I don't have to use human effort to do that. So as an attacker, a lot of the AI ML techniques currently are being used at the front edge, trying to get you to click on something, not so much on the back end. Once you clicked on it, there's much more manual processing in terms of actually leveraging the fact that I have now infected your machine. For the defender, we can actually use it broadly kind of as that defensive membrane to kind of figure out what should I pay attention to and what should I not pay attention to. So AI and ML are used by both parties. They're used for different things.
I was doing a white paper for a security company just recently, and one of the things they were saying is that their system actually doesn't wait for an attack. It looks for a computer behaving unusually or in a way that they wouldn't expect it to, and then starts highlighting, feeding into its database as to whether that means it's at risk. Is that the sort of thing we're talking about on a small scale?
Yeah, I mean, I think it's a combination of techniques. I think the danger in taking that approach that you talked about is that it is somewhat noisy, right? I mean, it presumes that environments that have large numbers of humans attached to them, like carbon-based life forms attached to silicon-based systems, that the carbon-based life forms will behave in a relatively predictable way. And humans being what they are, they will do unpredictable things. Now, the question is, how much unpredictable stuff will they do? And what is the volume of noise that you as a defender will need to look at in dealing with it? So I think you have to basically use a combination of techniques.
Oh, yes, yeah.
You have to use both the notion of what is unusual, but combined with some notion of, and would it be valuable to an attacker? Would this unusual action actually have value to an attacker? And so for us, it's really that approach of thinking, of trying to kind of capture the mindset of an attacker and view those unusual things that we might see through the lens of, well, would this be valuable to an attacker, or is this just like Joe on vacation in Hawaii accessing files that appear to be at 3 a.m. here? He just happens to be in a different time zone.
Yeah, so I suppose, the other thing is that sometimes you'll find a program that's got a payload hidden in it somewhere will take up undue amounts of processing time. I suppose that's where the attackers, artificial intelligence, machine learning, might well start to realize that systems are becoming wise to the fact that we're concealing our activities under these particular programs, so we've got to do something else.
Yeah, I think it's always kind of interesting. You can view the techniques that the attacker used by viewing them in terms of how unusual they are within the environment you look at. The other way of, quite frankly, detecting a sophisticated attacker is by the techniques they attempt to use to create stealth. As an example, you might look at the variability of certain kind of activity as a means of detecting that this is human behavior, right? So if it's variable, it's human. If it's if it's regularized, it's machine. Now, attackers will then say, well, I'm going to try and hide human behavior in this other channel and make it look very regularized. But in some senses, when you kind of go out of your way to make something look normal, it leaves behind traces of somebody's trying too hard to look normal. So it's this weird thing. I mean, think of it almost like a game of poker, right? I mean, when somebody's like bluffing too well, then that itself is a tell, right? So you have to kind of find, as an attacker, the unpredictable thing is when the defender is using kind of ML and AI, exactly what are they picking up on? And when you train up these deep neural nets, the thing to realize about these deep neural nets is, like, let's say I train something up that's 64 layers deep, 1,000 nodes wide. So now I've got 64,000 nodes that have captured some nuance of information in them. Even to the person who has trained up this neural net, it is unexplainable exactly how this neural net works and what subtleties it picks up on. And so to a large degree, as you kind of get into deep learning, you end up with this notion where it's very hard for the attacker to actually be able to reproduce exactly what would set off an alarm. Whereas traditionally, when we've built products in the cybersecurity space, if you got a hold of somebody's security monitoring tool, you could experiment and kind of very predictably figure out, okay, here's the edges of what it can and cannot do. But an engine that runs inside of a customer's environment, observes customer behavior inside that customer's environment, it's unknowable to the attacker exactly what it has gleaned out of that environment, and in fact, what silent tripwires exist as a result of that. And so it's that unpredictability that makes it harder for sophisticated attackers. It doesn't make it hard, quite frankly, for the people doing things like WannaCry, which, while it hits all the news everywhere, was not the most sophisticated of attacks. It was just a particularly fast-moving and malicious attack, but not the converse of the low and slow attack that stays stealthy and is unobservable. And so those are two different things, quite frankly, to also consider.
Broadening it away from the security space as well, I'm
Sure.
just thinking about how human skills need to be changed, and how we need to change ourselves, and how we need to adapt if the machines are going to start thinking for themselves. I'm assuming an awful lot of the very repetitive tasks, very boring tasks, will hopefully just sort of go away.
I think in the age of industrialization, one person's boring and repetitive task is another one's paycheck. And so I think there's obviously a lot of dislocation. We can at one level kind of look at taxi driving and truck driving as boring and repetitive, not being either taxi drivers or truck drivers. And on the other hand, if we suddenly displace 3 million people who are making their living at it, I think that's one notion. I think historically we've looked at automation. If you're in kind of the white collar industry or in the knowledge industries, you've kind of viewed automation as something that won't touch you. I think with AI, it will touch fair numbers of things. Like if you're a law clerk and your task is to go read a whole bunch of material about pre-existing cases and highlight out of that things that may be relevant to a lawyer in a particular case that he or she is looking at right now, I think the notion that that kind of reading of natural language and understanding things out of that and highlighting things out of that can't be automated, I think is certainly not true. I think, efforts to read things like, radiology files. And again, similar to kind of the car example that we gave earlier, the self-driving car example, I think over a large corpus of data, you can come to the conclusion that on average, an automated mechanism that reads these radiology files is more accurate than a human one. Now, that's not to say that there aren't extraordinary human beings that are kind of in the top 10% of their craft that won't outperform machines on those tasks. But the question ultimately is, when you make policy decisions at the aggregate levels, if you're the NHS, right, you're going to look at the law of large numbers. It's almost akin to kind of what Starbucks figured out about, at a much simpler level about their coffee machines, which is that 10% of their baristas could outperform the automatic machines and make a better cup of coffee than their automatic machines. But the other 90% actually underperformed automatic machines. And so they decided to go with automatic machines everywhere, because overall, within the large numbers, it meant better coffee. Didn't mean, again, that you couldn't come up with 1 or 2 or 10 exceptional baristas that could outperform them. And similarly, you're going to have 10 or 20 or 100 radiologists that can outperform the machine. But over time, these kinds of repetitive tasks where you actually benefit from doing a lot of it and having a broader perspective and having done it millions of times, those things ultimately, machines will get better at. And humans, I think the notion that you can have a job, a career in one job for your entire life has already kind of disappeared. And I think we're all stuck with the notion that we have to reinvent ourselves. If you're in the current generation, or if you're currently in your 30s or 40s, you've probably reinvented yourself 2 or 3 times in that time frame. I think by the time you get 30 years down the road, by the time you're in your 40s, you will have reinvented yourself 7 or 8 times. And so I think the difficulty that we have to kind of deal with as a human race is, what is the rate of change that humans can rationally adopt and be happy with, right? If you have to reinvent yourself every 2 years,
Yeah.
That's kind of a hard thing, right?
It's also it's a pace of change, isn't it? I mean,
Correct.
you mentioned the idea that one person's boring drive is another person's paycheck. I take that point
Yeah.
completely. We saw it happen to the typing pools in various corporations. I'm sure a lot of people were very pleased to be able to get rid of the boring job as long as they had another boring job to go to. If you were dependent on being a person in the typing pool, maybe less fun, but it couldn't be stopped, because once it's doable, once every executive can have a PC and basic keyboard skills in front of them, then it's done. So, I mean, thinking about this, sort of say 5 years out, where do you see this going? And, should people be nervous about machines making decisions for themselves?
I don't think nervous in the context of, Skynet. I mean, we're far removed from, the reality of something like Terminator, what's called kind of generalized artificial intelligence. In other words, the notion of something, a machine that's not trying to just solve a constrained small problem, but that has been given agency to kind of just go around the world and do whatever it pleases. So I don't think I would worry about it at that level. I think that the questions, the political, economic, and other questions, which are always kind of the case, is when automation comes in, and this is another kind of wave of automation, let's say automation on steroids, right? What happens as a result of that dislocation? I think from a policy perspective, we have to think about that. I mean, I think the term Luddite, a lot of people tend to think of Luddite being a term coined for people kind of against technology. But if you actually go look at what happened and where that term was coined, it was not really about people against technology. It was people against technology that effectively caused them harm, economic harm, and affected their livelihoods. And so as we gain these additional benefits through this automation, if we don't have additional work to put these people into, then what do we do as a society, right? And people have thought about all kinds of economic impacts. If you do the thought experiment and say 50 years from now, all the goods and services that you could imagine producing in the world would only employ 10% of the population or 20% of the population or 30% of the population, what do you do with the rest? Does everybody become an artist? Does everybody make their own TV series? What are the limits to how much we can ultimately create and where we can put individuals? I think in these AI companies, what you see in the Facebooks and Googles of the world, you see a vast amount of wealth created with a relatively small number of workers. So these are not like your industries of the industrial age that suddenly will employ, 500,000 or 1 million people. These are relatively small, compact industries that will produce phenomenal wealth for shareholders and a relatively modest number of employees. And then the question becomes, what do we do with everything else? So I think the bigger arguments here, the bigger questions here are really economic policy. I don't feel we're talking about it quite enough in the public sphere. I certainly don't think that's true in the US. I think even in the UK, there tend to be kind of more immediate now kind of things that prevent us from thinking about the next 20 or 30 years and how anthropologists might look at the human race, through a mirror from 30 years back, from 30 years from now, looking back, and how do we really work our way through this window in time? That's, I think, the big question.
That is a very big question, although perhaps the partial answer might be that if we were still in the 1980s or whatever, 30 years ago, it's still just about the 1980s, then looking forward to now, we've just been discussing companies like Google and Facebook. We wouldn't have had a clue about the Googles and Facebooks because we wouldn't have been able to conceive, certainly not of a social network, or, perhaps some really far-sighted people might just have been able to, because the web had just about been invented. People might just about have started to conceive it. We don't know what else is coming and replacing jobs that we haven't actually conceived of yet, and that's pure speculation, I grant you, but it is based on historical precedent.
Correct. And I think the human race in general, I mean, you can go back hundreds of years, right? The notion of a dystopian future has always kind of lurked in human consciousness. And the question is, at some point, will our notion of dystopia actually come to pass, or is it just a thought experiment that we like to play and we'll figure out a way forward and we'll figure our way to a better future? And I think we tend to always be nostalgic looking back 100 years or 50 years about the golden age of whatever. I think it is mostly nostalgia. I think if you could actually transport yourself back 50 years ago, you would not necessarily prefer to live in that world. But yeah,
well,
the human condition is one. Yeah,
I might, because the Beatles were still around, but I wouldn't want to go to the dentist. Can we compromise on that?
we can absolutely compromise on that,
Okay.
right? But that is like, how do you think about the future, and how optimistic and how pessimistic, and what is the balancing act, and in thinking about the things we should be talking about now to actually attempt to affect those pathways to the future. That's the hard thing, right?
Absolutely. We are running out of time now, so thank you very much indeed for that. And we really ought to be talking about the near future rather than the far future, regardless. But could you perhaps finish by telling us where listeners can find out more about you and your organization?
Sure. You can find us on the web at vectra.ai. So nice and short and sweet. And if you want to see me on Twitter, I am OK Tavakoli. That's letter O, letter K, and then Tavakoli.
And I seem to have been mispronouncing your surname as Tavakoli the whole time. I do apologize. It's Tavakoli, everybody who wants to actually speak to you. Thank you very much indeed for joining me. Oliver Tavakoli from Vectra. That's great.
Thanks, Guy.
And many thanks to you for listening. That was the Near Futurist podcast with me, Guy Clapperton. I'll be back in 2 weeks' time, as always. Don't forget to have a look at the website at nearfuturist.co.uk. See you in a fortnight.